Deal. I'm cool with that. Okay, we will popcorn through this. So right off the bat, what does it mean to factor something?
Keep something like the same, but like change it.
Okay, so I'm okay with both of those. We're going to say that rewrite as the product of smaller pieces. Now, those pieces are called factors, but I'm okay with just calling them pieces right now. Now, with factoring, just as a quick reminder, and you guys did a bit of it last year, do you guys remember doing all the factoring stuff last year?
Yes.
Okay, Carson, Raylene, Andrew, Apple, what do you think? You guys remember how to factor? Do you remember what it is that we're doing when we factor?
Distribute, like combine like terms to make it smaller.
Okay, so kind of. Distribution is going one way, like multiplying stuff is the exact opposite of factoring, but they're certainly linked to each other. So we're going to build up to this. You guys first saw factoring in probably like 5th or 4th grade, and you weren't even aware of it. So we're going to go ahead and just take a trip through time, and we're going to just gloss over middle school because I have no idea what middle school factoring looks like. But I do know what it looks like in the elementary, and I know what it looks like in Algebra 1. So check it out. Help me factor a number. We're going to factor 18.
1 times 18, 2 times.
So for this, yep. So we're going to build a number tree is essentially what we're going to do. Now, when we do this, we want it into the smallest possible pieces. Now, there's no right or wrong way to start. There's some more convenient ways to start, but 18, I think we can rewrite it as the product, which means what's a product? Multiplication. So give me any way other than 1 times 18, but you're certainly right. Give me a way to get to 18 with two numbers. 2 times 9. Is there another option that we could have taken? You could have done 3 times 6, and it doesn't matter which way we start. Okay, at this point, we're just going to keep looking at stuff until it gets smaller. Now, I'm going to make this look, and that seems weird, but I'm going to make it look a little bit more like factoring instead of just doing 2 times 9. Do you guys agree that this still says 2 times 9 here? Okay, can we break down 2 any further? No. Now, I'm going to just let it come along for the ride. It can't go. If it can't factor any further, we say it's what? It's a prime number. Do you guys know the prime numbers? What's the first prime number? Nope. 2. A number is prime if 1 and itself are the only things that go into it. 1 doesn't work because it's 1 and we've already used it. 0 doesn't work because 1 times 0, but you could make the claim. Okay, does 9 break down any further? 3 and 3. And at this point, do these break down any further? No. So right now what we have is the prime factorization of 18. That's it. Now, you might be able to write this a little bit differently. Somebody could argue, I think reasonably, that it's 2 times 3 squared, and that might be just another way that you write it, but this is completely factored. This is a different way to write the number 18, and that's it. It's just a different way to write it. Do we all agree with it? I want you to factor one more number for me. I have 2 numbers in mind. The first of these is 45, and then I want you to factor 101 as well. Cool. I will give you guys a moment. Build your factor tree. I want the prime factors at the end of your problem here. So 18 can be written like this. 45 can be written like this. And I might be trying to pull a quick one on you. What do you think 101 is? It's prime. We can't factor this number. Okay. Now, This is what factoring looks like in elementary school. And my guess is if you took elementary math, which I assume everybody did at one point, do you remember building factor trees like these? You don't remember doing this? Interesting. Do you remember doing this, Carson? Okay. Did you go to school here? Weird. I bet you did it and it's just not a memory. Same thing. I bet that you have also done this, depending. Because I think. Okay. I bet you did this, but that's okay. Do you understand this, whether you did it or not? Okay. So when we jump up a little bit, we can do the same thing with expressions. Now, we're just going to build this up. So we'll just go ahead and say, we do this also with, and this is going to be an ugly word, but we'll pick it apart. We're going to say polynomials. Now, we are not going to, I'm not going to test you on all of this, just so you know. I'm not saying that because I want you to zone out and not care about it. But assuming that you took Algebra 1 last year and Geometry this year, what class do you have to take next year? Algebra 2. Now, Algebra 2, you have to remember a ton of Algebra 1 to be able to do it. Now, not necessarily remember it perfectly, but if you don't practice something for 18 months, something specific in math, are you going to be able to do it after a year and a half? No, we'll do this a few times, but we can do this with polynomials. Now, you guys probably have seen this word. What does poly mean? So penta means 5.
Isn't that more than one?
Multiple, many. So this is just many. And a nomial is very specific to math, but this is just expression in one variable. Now, that's not really true, but it's good enough for our purposes. So we have many expressions with the same variable. That's all that this is saying. Now, do you want to hear my fairly controversial joke that I have about this language? Okay. So we can do this with many nomials as well. Now, as we go through this, I'm going to write some words on the board here that I think you guys should have as well. You all like flowcharts, I assume. Everybody loves flowcharts, and I'm actually just going to use this program to help it out real quick, but I want you guys to get the following flowchart for me. So, check it out. When we're doing this, right off the bat, we are always going to check, eventually, let me type. It's not funny. I don't know what's not funny, but it's not. We're always going to start with this. And what are we starting with? What does GCF stand for?
Greatest common factor.
Greatest common factor. Okay. What we are building right now is essentially just the roadmap that one would take for factoring stuff. Do you want to, should we just do an example with GCF right here? Okay. So here's like our factoring checklist, and we're just going to see. Okay, don't like that, but I can undo it. So let's try one out. We're going to list these out, and just so you know, the next one will go down, and we'll just do an example there. So let's factor the following. I want x gross. I'd like to start using this program. We'll see if we actually do or not, because it does some really cool stuff. If I have x squared plus 2x, do they both have x as their variable? So it is a polynomial. There's many parts of it with x in it. Specifically, how many different parts are there? 2. So what's the root for 2? You don't ride a 2-sickle around town. You ride a bicycle, right? 2. This is a binomial. Does that language sound familiar?
Yes.
Okay, 2-nomial. Now, as we look at this, if we're looking at GCF, and it's the only type of factoring that we're after right now, is there something that goes into both of them? This one, if we wrote it out, do you guys agree x squared is literally just x times x plus 2 times x?
You want to start
I would.
with GCF?
Yep, I would write that. And you can just write GCF. Now, we don't normally factor it like this when we're doing stuff, but if we want to view it out, what do they both have an x, right? How many x's does this one have? There's 2 x's, and this one has just 1. Could I take 1 x from each of them? Now, when we actually write this as factored, we would get an x, and then what stays in here then? There's 1x. That is x times x. And there's bits and parts of this that I love and bits and parts of it that I hate, unfortunately. This program is much better for notes, except I don't like the way it writes. Okay, when we looked at this, do you guys recall doing something like this in Algebra 1? Now, normally we don't do this step here. We just view it as it exists at this. But right here, we have factored using GCF. Here is a factor, and here is another factor. I'm just going to say factor, and we'll just make sure that we have it. Here's a factor, and here is a factor. This is just a different way to write x squared plus 2x. Now, the reason that we would do this is not really part of what we're focusing on right now. It turns out it makes it really easy to solve stuff if you can do this. Okay, we all remember doing GCF, I imagine. I want you guys to do one more for me. I want you to factor, using only GCF, the following. Let's make it 9x cubed. I got to think this out. Minus 36x. And I'm going to switch over to the other program. I might have already decided I'm not going to use this, except sparingly. 9x cubed minus 36x. So I'm just going to catch up. We had GCF. And our next one was 9x cubed minus 36x. Now, if you struggle to factor this, that's okay. When we think about factoring, there's a couple ways to do it. I like to think about it as division, but you can think about it as the opposite of multiplication if you'd rather, which is really just division. Okay, check it out. I'm going to look at numbers first. Can we both agree that they have an x in them that's going to come out? This has xxx, there's 3 of them. This only has 1, so we'll take out 1x in a minute. But people get goofed up when we try to mix and match these. Is there a number that goes into 9 and 36? What's one number that goes into, preferably the biggest, but if it's not the biggest, does 9 go into both of these? So when we're thinking about factoring, what I would encourage, if we're just taking little steps, when I take the 9 out, in my mind, what I'm thinking is, if I took this and divided it by 9, what would it leave behind? And I'm looking very specifically at this. If you took 9x cubed over 9, what's left? X cubed. So if we did that, we'd have an x cubed. And we didn't really do the GCF here, not yet. We did a common factor. What if you divided this 36 by 9? 4, and there's still an x, right? Now, even if we didn't catch the greatest common factor, because we didn't, right? We just took out the 9. What else goes into these? X. So if I didn't do it in one step, that's okay. I still have the 9 out front. There's an x now, because I'm going to take an x out. Raylene, if I took one of the x's out of x cubed, how many are left? Good. And Andrew, if I took an x out of 4x, what would be left behind? So I like where your head's at. Let's say, forget about the 4x. If I took an x out of x, like if I divided it, what would it leave behind if I divided by x? What's not quite? What's x over x? Anything over itself. What's 5 divided by 5? 6 divided by 6? X divided. Good. And there was a 4 connected to it, right? So it would just be a 4 here. Now, as we look at it, if I'm going like way too slow, I can speed up. I don't remember. GCF, do you guys agree with this? Does it feel okay? Can I speed up a little bit? Okay, so here's the big one. We're going to take a weird jump here, Lily, just so you know, because you guys learned it last year. One of my factors is 9x. One of them is x squared minus 4. Are these 3 all the same expression, just written differently? Yeah, so it doesn't matter. They're all the same thing. They're just written differently, just like 18 could be 18 or 3 times 6 or 2 times 9. We're just seeing it written differently. Okay, so from here, GCF, deal. We're going to take a big jump here, And we're going to skip over the binomials for now, and we're going to discuss briefly trinomials. What's up? Kind of. Now, for trinomials, there are a lot of different ways that one can factor these. We're only going to learn the very first way today, and we might do this again tomorrow, but I promise it won't be as slow as what we've done so far. There is one method to rule them all with regard to trinomials. You guys saw a bunch of different shortcuts last year. We'll deal with those eventually, but for our purposes in here, I'm essentially pretending like you've never done this before. We're going to talk about grouping. Okay, now for grouping trinomials, the basics of what we're doing is as follows. We are going to rewrite, and I'm going to suggest some lazy language that just works nicer. Trinomial is fine, I think. We all know that tri means what number? Okay, so this is going to seem stupid for a second, but I think that it's a good change. Instead of a trinomial, anybody opposed to me saying threenomial? Like, it sounds dumb, kind of, but are we still on board that that is still tri and three? Okay, when we group, we rewrite a threenomial as a fournomial. Okay, and this is the only reason that I use it, because if I say tetranomial, you probably have no idea what I'm talking about. Fournomial makes sense. We are going to rewrite threenomial as a fournomial and group. And I'm just going to say and group. Now, the way that this looks, we will work out like, here's a set of steps. How many of you think you remember how to factor by grouping? Lily, you better have it. I'm going to give you one here to try, and then you'll have a better answer for me, and we'll work out some kind of guidelines for this. So we're just going to say, hey, factor. And then just so you guys know, I don't think we use it in here, but if I say, what's the F word I need? It is not the one that probably comes to mind when I say the F word. 90% of the time it's factor. Factoring is the F word in here. It could be FOIL. All right, so here we go. For our first one, I want you guys to try to factor for me x squared plus 6x plus 5. And Lily, I can give you some harder ones if you'd like, because these are going to be chill. It won't hurt you to do some of the easier ones, but I'm going to give you guys like 30 seconds, chat with your neighbors. If you can remember how to do it, awesome. If you cannot remember how to do it, awesome. I'm good with it. Any recollection there, Carson?
Kinda.
What do you think?
Just taking it out and doing the same thing.
So kind of, but what goes into x squared, 6x, and 5?
1.
And if I just factor out a 1, nothing changes, right? Like, there's nothing there. And Ray, this might look different than...
I was definitely doing the work. Also,
Is that Korean?
No. I have tried to learn Korean, so it might look like Korean.
It looks like Korean and Japanese.
But then I accidentally drew a symbol
Yeah.
that looked very bad on accident.
Fair. Recall? Okay. So let's check this out. Now, we'll do today and tomorrow with factoring stuff, just so you guys know, because we're not going to get through all of it today. And I don't expect you to be perfect after the end of 2 days. You were probably starting to get the hang of stuff really well towards the end, like April-ish last year in Algebra 1. It's starting to feel good. And then you haven't used it for the last 6-7 months. Of course, it's gone, right? But
You really got at this.
that was not intentional. Okay, so check it out. 2 things that I need from you. The first is if and when you don't understand something, immediately let me know that you don't understand. And then second, if you recognize that I do something different than Mr. Russell might have last year, I guarantee we're doing the same thing. I know for a fact that me, Mr. Russell, and Ms. Jarvis all approach factoring essentially the same way. Okay, so if we look at this, 2 questions for you. Did you guys ever use factoring tiles? Which you might not even have a clue what I'm talking about. A factoring tile is just, there are some squares, and you don't have to draw these right now, that if we said this square had dimensions x by x, what's its area? It'd be x squared. And then typically we would use red or blue for positive or negative. Let's say that this was x by x and it gave us x squared. If I said that this piece right here was a 1 by x, what's its area? X. Have you guys ever seen this stuff that I'm doing right now? Okay, so if you don't understand factoring at all and it doesn't click after we do it today, talk to me. I can show you a different way to do it if you're more hands-on and you want to physically touch something. But let's check this out. So here's what I'm going to do. I would never include the number except in this very specific situation for teaching purposes. Is there a number in front of x squared? There is a 1 there, right? We don't write it. I'm going to write it. Now, once I write this 1, remember, we are going to rewrite this thing using 4 terms instead of 3. I'm going to multiply this 1 and this 5. And what do these multiply to be? So you're right with everything, but I'm only looking at the numbers. Do we agree it's 5? Okay, once we find this, here's a question that comes back to factoring that's probably going to start ringing the remembrance for you. What multiplies to 5, but adds up to 6? And where did I get my 6 from? I didn't pick it out of thin air. The 5 is obvious, right? The 1 times 5 part. Where'd the 6 come from? There's my 6 right there, right? Okay, we're going to pick up here tomorrow. What I have for you tonight is a possible assignment. You guys all took Algebra 1 last year. Okay, at the end of last year, what happened with all of your Algebra 1 notes? If they went in the trash, I get it. I used to throw my stuff away. If you have them, if you know where they are, I would encourage you to try to bring them tomorrow. If you have your Algebra 1 notes from last year, please bring them. There's no homework tonight, which means you guys can all hope and pray and wish for the Dallas Cowboys to win tonight. Or not. I don't know. I picked them. You are just all over the place today, Ray.